Okay, this session I'm working on SimpleArchiver. This session I implemented file format 7, which is the 8th file format, since the first one is number 0 and so on. The previous file formats store the compressed chunk size first, and then the compressed chunk. That's how the previous file formats usually did things, but it used a temporary file because you couldn't know the size of the compressed chunk until after it's been compressed. And I didn't want to seek in the output file, otherwise it wouldn't be streamable. You're not allowed to seek in a if you want to support streamability, which is like piping input and piping output. In other words, you could stream an archive into SimpleArchiver through a pipe, and it can extract files, and you can create an archive and stream the output archive from SimpleArchiver as well. So that is why temporary files were used in the previous file formats, because it needs to know the size of the compressed chunk. File format 7 introduces chunked encoding, which is something I noticed in HTTP 1.1, which is basically a way of serving data and the size of the data at the same time. In other words, it's like instead of having one large size and one large chunk, every time I get compressed chunk data from the compressor, I would store the size of that chunk, mini chunk, and then the mini chunk itself. And I'd do that for every piece of the compressed chunk without storing it into a temporary file. Now, this may have problems if the compressor often outputs very small amounts of data, but I think with more heavy compressors like XZ or LZIP, or 7-zip, for example. That's kind of more of an archival and compressor thing, but anyways. The more heavyweight compressors, I think it should work fine, but as for now, the results of the changes introduced in the session are still in the dev branch as by this recording, not merged into main just yet. So here I'm deliberating on how to store the size of the mini chunk. If I just used binary data, there would be a problem of determining when the binary data count ends, because there could be a null byte in the count, and then if I use a null byte at the end, if I use any byte at the end, it might be already existing in the binary data count before it. So I use ASCII style size, which is a base 10 number followed by a new line in ASCII format, which is not a binary format, but I can store these characters any way I want to in this, since I'm making the file format. So in between each every mini chunk starts with some base 10 digit in ASCII and ends with a new line, and then after that new line is the mini chunk, which has the size of the data, the size of the base 10 number just printed into the file. So yeah, using a binary size just won't work, because any delimiter you use could be existing in the count by mistake. File format 7 is basically identical to file format 6. The only change is what I've discussed, having compressed chunks be chunked to use chunked encoding instead of storing the size of it before the chunk itself. The compressed chunk, that is. So since file format version 5, every chunk data starts with an S and an A. This isn't a literal when it's compressed. Like the compressed chunk doesn't start with an S and an A. The compressed chunk starts with the compressed data. Uncompressed, it's an S and an A. So this is to support cases where empty files might be the entirety of a chunk. Otherwise, it would error out. So that was the whole point of introducing that in file format version 5. Possibly a whole bunch of empty file names or files with zero size into a chunk that might be compressed, might not be compressed. So it's a rare case, but I decided to cover it by having that 2 bytes prefix. Wait, I mentioned it as a suffix, but it's a prefix. I gotta fix that. Huh. Anyways, yeah, it's a prefix, not a suffix. Pre as in the start of the chunk. Suffix would indicate the end of the chunk. I guess I confused that. So starting out, I'm reusing the function used to archive file formats version 4, 5, and 6. And to make it pretty clear, that's what I'm doing by appending the next version to the function name. Since I'm creating a new file format version 7, I'm intending to replace the default write version to 7 as well. You can change the write version, you can change the file format version you want to archive into by using the write version command, or arg parsing. What am I saying? You can use the argument write dash format, I think. Write version. It was a write dash version. Here, setting the version to write down as 7 and as per the file format. Slowly reaching the point where the compressed data is written. Note that the change handles the data that's being received from the compressor, not the data sent to the compressor at this part of the program. Internally, SimpleArchiver uses pipes. It runs the archiver, or no, it runs the compressor or decompressor. When archiving, it pipes data into a compressor and receives the data from output from the compressor. And as for extracting, if it's compressed, then it would push the compressed data to the decompressor and fetch the uncompressed data from the decompressor, both times using pipes. To ensure that file format 7 doesn't use a temporary file, the file descriptor to the temporary file is by default null if it's a write version less than 7. This is a way of forcing it to not use a temporary file when I expect it to just use the chunked encoding. At this point, I realize I need to have a simple way of turning a count in binary data to a base 10 string that ends with a new line as per the file format. So I make a helper function for this. So there's a long pause here because I had to step out for something. Thankfully, when you record with asciinema, you can set a limit of how long an idle time is between changes on the screen. If you look at the bottom right, you can see the minutes going by, and I have it set to 3 seconds. Unfortunately, I've been away for like at least 10 minutes, so it's a little bit of a long wait, but it shouldn't be that long now. Okay, maybe it was more like 20 minutes. I don't remember. Ah, I'm back. Yeah. Must have been when the screen powered back on, but the dimensions of the terminal changed for a moment because, yeah, just some weirdness. Anyways, yeah, just working on the helper function for turning a value into a base 10 string with a new line at the end. Because it's a C string, I need to also account for the null terminator at the end. So characters, like character literals in C and C++, the single quote 0 to 9, and then a single quote, that is a number in ASCII actually, with the type of character. So you can use those character literals as numbers if you wanted to, which makes the arithmetic in this conversion handy. So there's an edge case if the value is 0, handling that here. Checking the unit test. Treating warnings, or fixing warnings. So the test passed, which is good. writing directly to a file descriptor that's a type file. The C standard library provided new things. With Unix, file descriptors are integers, just plain old ints, int. C standard library has its own type of file descriptor, which is a uppercase FILE pointer type. They're kind of different, but kind of the same. I guess if you want portability, it would be better to use the C standard library file descriptors. In C and C++, literal strings can be concatenated. You just don't put anything in between them except white space. It's very strange syntax, but once you get used to it, it's not that bad. It gets strange though if you have like hash define something string with the double quotes and everything. If you have those, then you can literally put those next to each other and they would be concatenated when it gets compiled. And this part is handling writing the data after writing the mini chunk size. Turns out I did need to enclose off that part with the right version. There's only one small part of it that actually writes to the output file. Well, normally it would write to the temporary file, temporary chunk data, compressed chunk data. Okay, at this point, I believe at this point I need to add code to handle writing the last chunk, which is a 0 in a new line. So at this point, I think I take a step back and compile and see if this works. Well, I can't test it completely because I only implemented the compressing part, not the decompressing part. Or in other words, the archiving part, not the extracting part. Not just yet, anyways. Just some minor typos to fix. Otherwise, the archival part is correct. At least at the time of this recording, I believe it is correct. Just need some testing to be more certain. Now, since I don't have a working extractor yet, I sometimes check the archived file with hex-editor. The problem at first is I'm not sure where to find what I'm looking for. So there's going to be some flailing about in the hex-editor at first. Sorry for that. I know that the new line is a 0A in hexadecimal. So I try to search backwards from the end to see the chunked encoding numbers with the new line at the end. Turns out compressed data is just about like random data in a lot of cases. There's a lot of instances where 0A hexadecimal shows up. So finally I decide to do the right thing, which is count in a calculator of sorts, or Python that is, the offset from the first mini chunk to the next one by adding the size. Turns out it's BAD0. Kinda sounds bad, but it's just a hexadecimal address. And the next one is right there, about 32 kilobytes probably. No, maybe less. Not exactly 32 kilobytes. I know 1024 is 1 kilobyte. So 32,768 or whatever. Maybe that's... I don't really remember. Kind of arbitrary. Not that big of a deal. Since I'm satisfied with the chunked encoding archive creation working, as following the first mini chunk size to the next one seemed to work, I then test if the existing file format, number 6, is actually still operational, just in case I broke it. It's possible, since the same function is creating file formats 4, 5, and 6. And now I'm working on the extraction or testing part, or the decompressing part, that is. Reusing this function so I don't have to redo all of the file format. After all, the only thing that's changed is how the compressed data is stored, and eventually how the compressed data is parsed. Note that most of my print lines, well, all of my print lines are printing the standard error. I have to absolutely always print the standard error, any diagnostic. Because if I print a standard output, it's gonna break streamability. Because on standard output, if I stream to output to standard out, that's where the archive data is. So any print line to standard output will break the it will cause malformed data to appear in the output, standard output. Thankfully, there's a second output stream, and that's standard error. So that's what I use for printing diagnostics and stuff like that. Slowly reaching my way to the point where compressed data has to be handled. Eight bytes being 64 bits for the size of the chunk if it's not compressed. Since I don't know the chunk size in advance, because chunked encoding, you have to parse the encoded chunk to get the size. That's one trade-off. When compressing, you don't have to use a temporary file, but when decompressing, you have to parse the compressed chunk to get the sizes of the entire chunk. It's a bit difficult to figure out where I need to make my changes without breaking anything. So there are a few criteria to check if a chunk is compressed or not. One, since file version format 6, if the compressed bit is set, then it is compressed. Otherwise, if the is compressed bit is set, which is set at the beginning of the entire archive, and for the purposes of file format version 7, I need to absolutely know if that current chunk is compressed or not. So there's some thinking about how to handle the Boolean logic. In this case, I'm checking if it's not required to fetch the chunk size. The chunk size is definitely there if it's uncompressed. SimpleArchiver has a feature where if you use white blacklists to select arbitrary files in the archive, if an entire chunk is deemed to be skipped, it can skip that entire chunk during processing, testing, or extracting. And there's a separate piece of code that handles that, and that's right there. I need to also handle this for write version 7, file format version 7, so that it correctly goes through the next chunk that's to be skipped and skips it properly until it reaches the 0 new line indicating the end of the chunk. Note that this file format is a binary file format. Any incorrect offset will mess up your entire parsing of the file format. There's a lot of talk about whether while loops are okay to have an absolute true or false or true in them. Like, some people argue against having infinite loops that can be conditionally broken out of with a break statement or a return statement. I'm of the opinion that infinite loops have their own place, but I would say most people are probably right to assume that it's better to have a well-formed while loop condition than an infinite loop that you break out of. But then again, it turns out that it doesn't fit every case, as far as I can tell. backwards conversion from ASCII to literal. Well, not literal, but binary, I guess. The characters from 0 to 9 are increasing in value. So you could just take any character within that range and subtract the 0 character from it. And that's basically a perfect conversion of 0 to 9 into a single value. I think I forgot to add code for a while that actually skips that actually reads from the input file descriptor to skip past the amount read. I added in later. It happens by the end of the session at least. At this point, I'm thinking maybe I should separate it out with a different branching statement to decompress. But I decide to modify the existing function being used to parse it. I get a little confused here, but that function just sets up the decompressor. It also happens to set the compressor too, but in both cases, it sets up piping into and out of the command. So I split off this piece of code into its own function. It's the same function where I mentioned I didn't finish actually skipping the chunk data. I think at this point is where I actually fixed that. This is where I actually read data from the file descriptor. I think I could have used fseek to just skip ahead, but I'm worried that might break streamability. So I forbid myself from using seek at all, and I just read instead. This function is too many arguments, but I don't know. I think it will be a huge pain in the neck to refactor it. Either that or set up a struct and pass just a struct to it instead of all that data. Could be a good place to refactor though, thinking about it. There's a lot of moving parts in that function though. The way the archiver works is it handles writing to the decompressor and receiving from the decompressor at the same time. I think the same thing happens when compressing as well. At some point, you can't keep on writing forever, and you can't keep on reading forever at once. You have to juggle both when handling piping data to and from a compressor. The issue I run into here is that a mini chunk size is not guaranteed to be smaller than the buffer I have set aside for this function. I think I got sidetracked just to change some constants in the skip chunk function. Alright, I probably was using it as a reference because I'm using the same similar code in this part to parse the base 10 number and the new line and then the chunk data. The mini chunk of a chunk. I don't have to worry so much about reads from a file descriptor not reading as much as I want it to. That's not that much. Especially if I'm reading from a file on disk. But it's possible. But I don't know. I'm not sure if by the end of the session I handle partial reads from a file. But I think that most of the time, if not all the time, you don't get a partial read from a file. On disk, that is. Yeah, here's where I handle what I was thinking about. The dynamically sized buffer that's not necessarily the same as the buffer given the hold buffer. Basically, I need to hold some state in between calls to this function because at one point I'm writing to decompressor, and at another point I'm reading from its decompressed data. So there is some state I have to keep track of in between writes and reads. And hold buff is a known defined size, but the mini chunk buffer I just allocated, not necessarily within that size, which is why I add something later. Yes, this double pointer buffer, a pointer to a buffer, that is. Notice that I keep size t and pointer types at the beginning of every at the beginning of all of this entire function call. Every pointer on a system is the same size, and size t is the same size as a pointer. Because, well, it's a 64-bit machine. By definition, it's an 8-byte pointer all the time. So this kind of helps with alignment, but if it's holding this many arguments for the function call, I'm not sure what it looks like in assembly, but it's definitely going to run out of registers to hold the arguments for the function. So that function call is going to be expensive the more arguments I add to it. I create the version 7 hold buffer in the wrong place. It doesn't last between calls to the enclosing function, write decomp or whatever it's called. It needs to last longer than the function I just put it in, which I fix later. My cleanup helper does not attempt to free a null pointer. Then again, trying to free null pointer, I think it's allowed. I personally think it's weird to try that, but if it's allowed, it's a nice guarantee to have if you use pointers really heavily. Now, because writing to the decompressor might not take all the bytes I send to it, I have to account for partial writes. I think I handle that eventually. Yeah, this is the part. I need to handle a partial write success. I kind of don't worry that much about conversion between a signed size t and a regular size t. Size t is unsigned, and signed size t is, well, signed. The only difference is the very last bit, the 64th bit at the end, is different. And I'm pretty sure that if you're using 64-bit values, you're very unlikely to get a value that large. Very unlikely. So I think I can say with some confidence that using the size t and s size t interchangeably should be okay as long as the value is guaranteed to always be positive. Now, if you were using a 32-bit system, and if you were actually handling up to 4 gigabytes of data in size, then that might be a problem. But I'm pretty sure that all these reads and writes to a decompressor should be less than 4 gigabytes at worst. Because naturally, a 4-byte pointer that's unsigned is 4 gigabytes at maximum. Which is why 32-bit systems could only have up to 4 gigabytes of RAM. Because, I mean, you can't really address higher than 4 gigabytes with just 4-byte pointers. It's okay to return a success here because it's expected to call this function repeatedly until a certain variable has been set to indicate that it's done writing. Like I said before, handling a decompressor, or in other words, a compressor, either way, you have to read and write to it at the same time. It will block eventually if you keep writing to it and not read to it. I hope I addressed that because I just spotted a bug. Yeah, I think I addressed it. Or not? Huh. At long last, the building and testing. Unit test passed. So the problem I ran into here, I'm pretty sure it's what I mentioned before, that the the temporary buffer that I created, the version 7 hold buffer, doesn't last long enough because I instantiated it inside the function that does most of the decompression. Well, I have to figure out that bug in the session first in order to fix it. So I'm kind of jumping the gun here talking about it, but yeah. Probably should have added these debug logs for errors in the first place. Well, I'm pretty sure I have them in there now, so So read decomp out to file is called per every file in the chunk, which is why declaring the version 7 buffer inside of this function is not good. The buffer has to last for longer than this function. For the entire chunk, it has to last. Takes some print lines to realize what's going on, but I get the hang of it eventually. Finally, figuring out that the version 7 hold buffer has to be somewhere else. Well, it has to be declared outside of this function at least. Finally at the right place. Same lifetime as the hold buffer. I probably don't need to declare this version 7 hold buffer everywhere this function is called. But for safety's sake, I define it anyways. But it definitely won't be used if an older file format is used. This project does maintain backwards compatibility with old file formats. That's the whole point of storing the version of the file format in the archive file. Testing seems to show that it works now. But it should be tested a lot further. I don't want to lose any data or cause data loss just because of a bug that I didn't catch. This project does not use a formatter, so I do that manually. Kinda accidentally erased a comma there, but I fixed that later. accidentally typoed some tmux command, tell what monitor or whatever screen this is. I guess they're called windows and panes in tmux terminology. Again, testing with an older file format version to make sure it doesn't break because of the changes I made. So this is basically it for this video. If you stayed for the entire 2 hours, dang man, dang. Alright, thanks for watching.